Hi, it's Gadget UK here again. I've got a bench full of parts here. I've got to be careful not to lose anything. This is from Keith McGerr. The guy is incredible. I haven't gone through some of his previous stuff yet, but I moved on to this just because, well, I'm trying to work my way through things here, and I've got boxes and bits and parts everywhere from things I bought myself and things I need to get around to doing. Some things like this from Keith and other people have donated things. So this one was next on the list, really, just to make some space, because this it takes a lot of space up, this stuff. And I'm keen to look at this because, well, it looks really cool. There's another product like this that may have the same heritage, I'm not sure. But you'll see, there's another video coming up from Jorgen Bilander, a few actually, from stuff that Jorgen Bilander sent me. And he's been working on, I think, on something similar that works off the parallel port, that allows you to, have a floppy drive on the parallel port effectively, or a hard disk, a virtual hard disk. It's come with this really nice case here, really nicely 3D printed. It's got a really lovely finish to it, precision printed, and it says on there SDBox. So we've got the case, then we've got this here. Now there's something else, AMI to RGB to VGA Ultimate. So that's quite cool as well. Again, it's got the 23, is that 23? Yeah, DB23, PCB, hen's teeth. Yeah, they are. It's incredible you've managed to get that. And I think all the bits required to assemble that. So that'll be another video, I think. I'll put that out of the way. But then we also got the Amiga SDBox V2 bill of materials here. So we've got everything, I think. I don't think he's excluded anything here. It's incredible. So we've got the PCB. We've got an Arduino or something. It might be a Nano, or yeah, it's a Nano. We've got another D-sub-25 for the parallel port, I think, and then we've got connectors, SD slot, I think, a Schmidt or something like that, or a Logic, 74 series Logic. You get these tiny little things, tiny little devices that got like 5 pins or so, and they'll have like 1 or so Logic gates inside there. So yeah, one of those there, another one there that's even smaller. Some resistors, capacitor, tantalum, more capacitors down here, an SD adapter with a micro SD in it, I think. I wonder what size that is. Let's just carefully try and pull it out. Wow, 32 gig. That's incredible. So put that back in. It's a nice fit, that as well, nice adapter. And some LEDs. So I think, and this bit is for the power. It says here, 5-volt power for SDBox off floppy port. So yeah, this is where he's got another D-sub-23 there, look. Wow, he's having some good luck trying to find those, isn't he? Yeah, it says there, hen's teeth. Doesn't that other, I think that other thing said hen's teeth on it as well, didn't it? So, yeah, we've got everything here, I think, to make a power adapter. And it says, note, you need a USB-C to USB-C micro B cable to power the SD box. And I guess that's what this is. I was thinking, did one of my phone cables fall in there? But no, look. Ah, look, it's USB-C to micro whatever it is. So, yeah, that's how you join them up. So, very, very, very cool. Let's just have a quick read of the cover letter here. Hello, Chris. Sorry for the delay getting this to you. This should not take the console whisperer long. I wonder what he's talking about. Let's talk to someone else. I found these a lot of fun and very useful. Now, very important, Chris. Do what you want with them. There's zero obligations to do any videos. Just have fun and enjoy them, as I know you will. Well, I definitely want to do a video. I do a video on everything I enjoy doing, is the thing, so I'm glad to share it with you. Many thanks for sending all this stuff, Keith, and thank you for your kind words here. Nano V3 is pre-programmed, so just fit. J Bilander, SDBox V2. So this is the thing, I'm ahead of things here, because J Bilander, and he's done quite a lot of changes, so this might be out of date by the time we get to the next video. Yeah, copy these files to Amiga on the SD card and format FAT32. Check the format, it should already work. Read the README on the SD card. Place copy SD0 and SD0 info into devs. So I think you need those maybe on your hard disk in order that they can mount this as a device, a parallel, storage device. Yeah, so some instructions there on how to set that up, and then links here, GitHub, Embert Heavy Industries, AMI-RGB. Oh, that's for the other one. That's for the VGA thing, isn't it? Many thanks, Keith McGerr. Thank you ever so much, Keith. That's incredibly kind of you. And it's incredibly amazing, because the time it takes and the cost it takes to gather all these parts and to put them all on a piece of paper like this, tape everything down, package it off, post it off to me. It's just absolutely incredible. I'm indebted to you. So I think we'll start by building the main PCB. Let's put the power adapter stuff out of the way on the case. Yeah, so I'm hoping that this doesn't detract from the Jorgen Bilander video. I don't think so, though, because I've been watching his developments on the stuff to do with he's been working on, and he's made quite a lot of significant changes as far as I can gather. It's like it's evolved and evolved and evolved. So this was sent to me about a year ago, I think now, roughly, maybe 6 months, and I've seen a lot of activity on Jorgen's Discord, his interaction with me on Discord over the last 3 months. So this, may well be superseded by what Jorgen's doing. I don't know. So let's get all the stuff out here. So that's the Nano. I always get concerned with these Nanos. Like, it's like all these little things like this, like Arduinos and Nanos. It's like programming them up. Programming them up is the for me is the trauma. I'm like, oh my god, how'd you do this one? And it's usually like USB on the PC. Then you some specific software, and you have to hold a button down when you power it on to get it into programming mode and all sorts of things. So yeah, I don't profess to be an expert on things like this Nano. I might need a programmer. I've got programmers, so many different programmers, so we will be able to program it, but yeah, it's a bit of an unknown for me right now, because, I don't do that sort of thing every day. Now, I spoke to Jay Bilander a minute ago, because I was worried he might be sending me one of these, and I said, I'm just building a V2. He's like, oh, did I send that? I said, no, it came from Keith McGerr. And he was like, oh, yeah. He says, I think I sent you a V3. So this is the other thing. I may have a V3 to build yet. I might do it in this video. If I do, it's not going to be much different, hopefully, in the build to this one. And I'll just cut to completion. I can't get that off there. It won't come off. There we go. So I'm just going to go straight at this. So it's, let's have a look. R3, R4, R5, R6, R7, all 10Ks. Yeah, so fast forwarding through lots of this building montage here. I've covered it so many times in so many videos. There'll be some links top right of videos where I show you a little bit more on how to mount some of these SMD components. And of course, I get quite pedantic about alignment of things and cleanliness and all that. It's not that important. If you put one on and it's at an angle and it's a big blob of solder, it doesn't really matter, does it? It's got to be inside an enclosure. You're never going to see it. So don't ever let my pedanticness put you off having a go yourself. Because if I was critical now, I'd go, yeah, I don't like the shape of that solder there. I don't like the shape of that solder there. I should have had a dedicated flux to these. The points where they were flowed right the first time, they look okay. They look pretty good. But these ones are a bit, you can see where the iron was pulled at a certain angle. There wasn't quite enough flux there. So, even though I am self-critical quite a bit when I'm doing things, not as much as I could be is the point. Yeah, the band goes to the dot, which is a kind of a good principle to remember anyway. If you do like these videos and you're not subscribed, hit the subscribe button down below. You can also hit the bell icon for notifications of any future videos that I upload. And I'm usually uploading videos once a week. Right, the other IC. There's pin 1 here, pin 1's there. Hang on. Pin 1's there. I think pin 1's here. It would be generally with a print on devices. Oh god. They're usually readable where you can see pin 1 there, but I can't tell if there's a dot. I think there is a little indent or something there. I'll do. And then just try and smush it around. The problem is there is solder on the top. So because there's solder on the top of those pins, it's kind of like floating around a bit. We'll just kill two birds with one stone right from the start here. Instead of reflowing at flux, we'll just add the flux on. We'll add some flux there as well. Solder points are terrible there. They really are. I don't usually struggle with things like that, but that has cheesed me off, if I'm honest. You can argue get the chips on before you fit the caps and things. There we go, I think. Is it that cap there, the corner of that cap just getting in the way? It's like soldering concrete. I think it's just the thermal mass of the pads, the ground and the VCC, that was making that particularly hard, but yeah, it didn't help the fact there was solder on the pads to start with. I should just use higher on that. maybe added some extra solder if it needed it afterwards. So let's get the SD into position. You can argue the best way to do this is to anchor it first. Look at the connections on that, they're tiny, aren't they? They're absolutely tiny. I'm trying to judge where it needs to be. Sometimes if you actually solder the solder like that, then it doesn't move as much. It has moved though, so I can, at least I can move this with the fingers. Yeah, that looks alright, I think. If you look at down here, we've got plenty of space to solder there, and we can solder those things. And in terms of the back, it looks fairly well aligned, doesn't it? A bit too far down here. You know, the solder needs to go under it, doesn't it, more or less? But if we get enough solder around that, it'll flow. It's just ground. Huge solder points there. Who cares? It's kind of what you want, really. It gives it structural security. You know, when you're putting a bit of force on cards, you know, out and stuff, it's not going to give way, is it? Look at that. It's like, how's the solder gone on the wrong side all the time? Now the problem with things like this, let me show you. See the metal edge here? If you're not careful, oh god, you can do that. If you're not careful, you can bridge these to the actual shield. I'm going to need to just keep adding little bits of solder here. If you would like to and are able to support the channel, please see the links down below for Patreon and Coffee. Right, I had to fast forward through that. My wife came in and she's got all sorts of family problems at the moment. We've got so many problems in our lives, it's unbelievable. How does this go on here now? Yeah, there's like little metal tabs underneath it, lifted off, which might sound a good thing. If you had holes, you know, receptacles for them to go in. So, I'll show you what I mean. If I flip it over, you'll see. Can you see? Hang on. I know it doesn't, it fits flat. I don't know. Oh, hang on, I've got it upside down, it wants to be that way. So we are on the side here, see this metal tab? And there's a metal tab up there in the middle of the thing. So it's going to go that way up, yeah, in order that the 4 pins can solder on. But there's nowhere for them to go. The holes here are not in the same places. The metal points are coming out like here. So it's going to... Why is that? What's this for here? The 4 points are there. Do you have to hot air solder it so that... Yeah, you do, don't you? Yeah, this underneath of here is going to be soldered onto that. I mean, it can make it quite structurally secure, that's nice. But like these wings, there's nowhere for them to go, is there? And in fact, it's not even going to join up because of those two things there. See what I mean? It's not like the underneath of this is going to be joined to there unless you have loads and loads of solder. But how do you get that on there? I don't know. 45 degrees like that. That will lower it at that point on the board. It may even, I was going to say it may align with the hole, it won't, the holes are nearer to the middle. I'll do the same on that one. It's a bit more in line with the pins, but the pins are still like a millimetre or two off. Yeah, this is the fiddly bit of this project, I would say. Everything so far, yeah, it's small and stuff, but it's easy enough to do. With a bit of practice and a bit of trial and error and a bit, you know, you might need to correct a few things like I did with hot air maybe. But trying to get this now right, well, it's going to be fun. I mean, the pins do go quite far back, don't they? So I mean, it could overhang it like that maybe. And the pins aren't going to be aligned. But if we don't anchor it on something sturdy, the tilting and wobbling and the unevenness and shape of it is just going to mean it's not going to bite. Like that might have got the can wasn't it? So that might have just got the standoff that I bent over a little bit actually. Yeah, I think it has. So you could argue bend those standoffs out and then it would fit flat. Because now it's going to be a wee bit launching look. And those aren't flat with the board look now. think I might be better off just trying to bend it with this. Yeah, that might just do it. I think what I do need to do though now as well is bend these things down, because I think those things are all floating up. I'll do it on the board. Whether I've bent this out of angle or something out of shape, I don't really know. So I'm going to try and now anchor it back on there again. Hope it doesn't move when I do this. Right, that looks fairly straight. Yeah, I think what I need to do though is press these here down, because I think one or two of these, like that one's down fairly flat. That one isn't, I don't think. Feels like there's a huge gap under those. It can't be right. It can't be the right connector. Go and get on that side as well, and then inspect it to see. Yeah, that's looking straight now. It's looking flat. It wasn't flat before. So, I mean, it's still pointing upwards marginally, and obviously this is going to be a bit fun doing this bit. Like, is the solder going to bridge, and is it going to go to the pad? Because they are kind of floating upwards a little bit. They aren't marrying with the board. Oh my god, this is going to be a trauma, isn't it? Oh my goodness. I think the antex is coming out in a minute. Something like that. Yeah, no, you can't bridge to that metal above easily. So, let's try that again. I'm going to need to zoom in. The points there are so small I can't even see them. The board was nice and tidy up until this point. One. Two. I think I need some more solder. Let's try that second one again. Oh, you! Oh, this is the problem, isn't it? And what's annoying is they're those kind of pins where if you do that, everything just bridges. Yeah, you can see that, one giant bridge. So, like, there is the tendency with something like this to go round and round and round and round and round, unless you get yourself a really fine tip. Those two are bridged, are they? I see a bridge in the middle. Those two look bridged to me. Oh, for God's sake. Right, that I think is joined. What about that? That second one. Third one. Fourth one. Oh, you twat. This is what I meant when I said, like, you go round and round and round with this magic roundabout. Cue magic roundabout music. If you're lucky when you use the braid, you might not remove all of it, and I think we've done that there. We've left enough. To be fair, this stuff's probably not hard. If you're used to fixing PlayStation 5s and Xbox 1s, the HDMI on those is going to be very similar. So that... I think everything's joined there. Yeah, that first pin is, you know, solder mask has come away a little bit there, and it's got a giant blob next to it. I don't care. Hopefully that'll be alright. If it doesn't fit the case, I'm going to put holes in the case, widen the case to make it fit. It's not too bad. If I rotate it like that, you can see we do have solder points. Nothing is bridged, I want to say. What's that there? I think that's just the plastic that's melted. Yeah, I think it's just a bit heating of the plastic here. No bridges though, and I think everything's connected. But look how scratched this is here, just from the constant heating. You could do with a bit of a UV solder mask on it. Got hair there. Anyway, that's not too bad. The LEDs is going to be an interesting one, because other than the fact on the LEDs one of the pads is square and one of them's round, like which one's which here, I don't know. No, that's going to be a fun one. I can imagine fitting the LEDs, finding the LEDs don't do anything, having to reverse them, take them off and reverse them. Yeah, and looking at the web page here, I can see the angled part of the blue plastic of the connector coming down there and saying that way, I think, which would make sense because I'm sure the power port on the Amiga is that way up. Yeah, with the narrow part at the bottom of, you know, near the table. So I suspect it's going to go this way on. It looks like that, doesn't it? So what I need to do now, though, is try and solder this in such a way that it's not like that. Yeah, it wants to be this connector on the, you know, that we're joining up here wants to be like that, not like that, or like that. Does that make sense? So the best way to do that is just solder one point. Right, so I think that's it. The other thing to size up is, if we take this out here, let me just get the wrist strap back on. How is it going to fit with that on? Like, do you need these pin strip things that are on this? I mean, you think so, but they might need cutting down is the point. Again, that's not got a pin 1 marking on it, has it? Let's just stick it on any old way for the moment. Like that. Because I'm not sure about this pin header here. Is that going to get in the way? It is. Maybe you're supposed to cut those down? I don't know. This is going to be a problem. Yes, I'm going to have to remove that serial connection. You know, 6 connections there for your RX, TX, blah, blah, blah. The photos don't show that fitted. So on the nanos that he's used when he's designed this, it didn't have that. So I do need to try and remove the solder from this. It's going to be fun. We've got such a tight space, and we're right next to the regulator as well, so you've got to be careful you don't bridge anything. Some of them look free, that one's not. That one's not. And look, there's nothing coming up. It just really annoys. That's got to be a ground, hasn't it? It's one of these things as well, you just move a millimetre and you've moved a mile. Oh no, I put the thing on the floor again. I'd say I'm going to move it to the floor in a minute. If one more thing drops on the floor, I'm going back to the floor. So if you're going to build one of these, try and get one that's got a nano that's not had that serial header fitted on it. Yeah, you can see that could be repaired. The through holes are in all the other ones. You can see that one was starting to just poke out a little bit there. Just press and rotate a little bit. Yeah, that one was starting to come out. But it's easy to see where that is. It's on this big connection here. Yeah, in terms of the alignment here, the USB is towards the tantalum. Right, I've sized it up inside the case. I don't even think we'll need to cut the pins down off this. And I've soldered that connector on there. I'm now going to solder this in place. I haven't programmed it up, but well, it shows you being able to program it when it's on there, so I don't think we need to, you know, have this separated before we solder it. So I think now we're pretty much there, aren't we? We've got a card and an adapter, we've got a case, we've got 2 LEDs, that's all we've got left to deal with here. But I think the next step is to go try and program it, and I'll stick the LEDs on after that point, and I'll cut the pins down at that point as well. Right, I've decided I'm going to cut the pins off now and clean up. Yeah, be careful not to ping these things into your eye. So you can see it connected up to the USB port here. Yes, the next thing I did was run build. There may have been some prerequisites how to install some libraries or something in the Arduino software there. And then once it's built, it's created the hex file, I think, and you can run Flash. I did have to edit the Flash batch file because the comport was wrong. I'll talk about that in a sec. Right, so you saw me program that up. The crazy thing is, I didn't read the notes. I never read the instructions. Pre-programmed just fit. So I didn't need to program it, but anyway, I programmed it up. You saw me, I had to compile it first. You saw me do that build, then Flash. I had to work out what comport the Arduino was on COM4, then edit the batch file there and run the Flash. Yeah, off camera, I ran it the first time when it failed, and I'm like, why has it failed? Can't find the comport. So I looked at the batch file and realised it was on COM4. It's the COM11, which was the original place it was pointing to. There'll be links down below to Jorgen Bilander's GitHub, but also the source code GitHub, because it's a separate repository. A different person created the original source code. Anyway, I now need to create this. Now, I've got an ADF that someone sent me that will allow me to boot from a disk that's got all the drivers installed, but they're on the card here from Keith McGerr. He's put them on the place there with some instructions where to put them. So I may just stick this on the 500 plus boot and copy the drivers across rather than use that ADF, but we can try that ADF in a bit. I've never seen that before. I've never seen one of these where it's not numbered properly. Let me go and see if we've got another one of those. I've got a bag here nearby. Yeah, so these are a bit smaller, but the numbering starts the same way. Yeah, pin 1 starts up here, and that's marked pin 1. That's correct, so yeah, I'm confident. Even though they're not the same size connector, pin 1 is in the right place, so I can solder that on. God, my solder's getting a bit low. Can't imagine there's much solder left on there. I mean, to be fair, the last reel has done me, I want to say 3 years. All the projects and repairs and builds and things you've seen on my channel I've done on one reel. I've been thinking ahead. What is that giant reel of solder I got from Dr. Andrew? My friend Dr. Andrew. Not the guy that has a YouTube channel that's also called Dr. Andrew. Just to confuse things. Because Electron asked me about that a few months ago. He was like, how do you know Dr. Andrew? I'm like, this is a different Dr. Andrew. It's not the Dr. Andrew you know. My Dr. Andrew is just a whole genius. He really is. He's a genius. He's studied advanced mathematics, quantum physics, wave theory, probability, artificial intelligence, neural networks, chemistry, metallurgy, you name it. And he was in IT, is the thing. He was just putting some of his IT skills to use in an IT role, but he's used all of his skills in different jobs, different careers. He's moved around, as you'd imagine he would with so much of a diverse skill set. But yeah, Andrew goes down as pretty much the smartest person I've ever known my entire life. People like Stephen Leary come close second. And Stephen Leary's a genius. It takes a lot of beating to beat someone like Stephen Leary in terms of intelligence. My friend Andrew, Dr. Andrew, is on a whole different level. Andrew's one of these people I don't know how he didn't win the, one of the Nobel Prizes or something at some point. He's so smart. It's what you decide to do with your life though. That's the thing with Andrew. Andrew could have excelled and did excel in anything he did really. But like he could have stayed in metallurgy, understanding metals and in manufacturing, fabrication and the engineering side of things. He could have used his scientific skills there. And he did for a period of time, but then just completely sidestepped to something else because he was a bit bored with what he was doing. It must be good to have such a diverse skill set like that. Right, that's fairly clean. Yeah, I could toothbrush and stuff. Or ultrasonic it. I'll wait till I got the other components on. Right, so anyway, that's the right way around. We need to get an electrolytic. Now, we need to think at this point here about this, don't we? It's going to go in here. It's very tight though. Oh, actually, it's alright there. You can see it's going to be okay. Yeah, anyway, the cap has got to fit in here, so you can't sort of solder it directly up like that. And where's the ground on that? Ground goes towards the white part. Yeah, you can't do it like that because it wouldn't fit inside the hood. You need to flatten it down, you know, fold it over like at an angle, maybe like that, so that it fits inside the hood. So I'll solder it on that way. In fact, the lid doesn't even fit on now. No, it does. No, it does fit. Look at that. That's tight, isn't it? Can you believe that fits in there? Yeah, so we've got all of these things. We don't need those. Those are useful to keep because I have those missing from a number of connectors. And then, which ones go where now? We've got these small ones. Those are for those. The big ones are for this with the nuts. And those are the ones used to secure. So you can sort of push these through like that. Yep, they should hold in place. Not that you need to screw anything into a port, but I like these little screwy things. I tend to use them. That's it, and we put our captive nut on one side. And our screw on the other. What I tend to do with these, yeah, and I've always done them this way, is do them opposing ways. So like, right, this is screw into that nut. There we go. This time put the nut on the side where the screw head was. You find them assembled like this, I don't know, it might be a common thing that everyone seems to do. And do it the other way. So, other than LEDs in the case for this, and I'm tempted to test this and then work out, let's take that out, work out which way the LED goes round. In other words, I could just bodge the LED through one of the holes and determine which way it is. Does that make sense? You can measure it instead of sticking it through, but anyway, we can get that in there. Is it a clicky one? Yes, it is. Yeah, the card's sticking a bit there. That's making a good connection. Anyway, I guess if we now go and find an Amiga, I'll go with the 500 Plus as I say, and we connect these two things together. So one of them's that's the fine one. Got to get it the right way around. Like, hang on, why is that not going in? That's it. That's very tight. And then that's going to go into there. Doesn't matter which way around you get it, does it? There we go. And we should be good to go now. Yeah, I've not thought this through, have I? When it comes to getting the drivers off that card, because they're on that card at the moment, onto the hard disk of the 500, we can't. We need the drivers on it to access this to start with. So I'm going to have to go and write an ADF to an actual floppy, aren't I? Right, so the RRG 500 here with the PiStorm. That PiStorm originally came from Sparks UK, so I'm very grateful for that. I never got around to doing a video on it, but I'll review it at some point soon. And obviously I've got a floppy drive connected at the back, and it's booted up, as you can see. It'll be interesting to test this with the PiStorm. Now we need to connect all this shenanigans up, don't we? So like, the external thing is going to go, hang on, parallel, it's parallel, isn't it? So it's going to go into that port up there. And then this is going to go into the external floppy drive thing. Now if I've got the right way up, it should be powered. And if we get the disc in the drive, that should be able to detect the device. Let's say, I think it's a 1.3 install, maybe version 2, that's got the driver. So let's see what happens with that. Power on. That's a good sign, LED. That means that's powered. It does take ages the PiStorm to boot, like 10 to 20 seconds. It's doing something. It's making an interesting noise, that drive, but it is rubbing on the cables. It's booted though. You can see that there, it's 1.3, isn't it? Plugging the mouse in. At least now I've got this disc, I could copy these drivers. You know, boot from the PiStorm and copy the drivers to the PiStorm hard disk. Do it that way. There we go. So Oh, we can see the hard disk from here. We've got games 1, work. What I'm not sure about now is where our devices. I think you have to go. Is it on Workbench 1.3? Mount SD card. Yeah, you double click that, don't you? I think. Maybe it's already done that. Maybe not. Oh, this is that point where it's not going to work, is it? I'm going to be like scratching my head for hours. There is a chance. Look, we've got a block problem there. And it's in German. I don't know what that means. A bracken is cancelled, is it? So, there's a problem reading the SD card. It's not a good start. And I can see it there, can you see it? It's like tempting, and there's the icon. Maybe it's not compatible with the PiStorm. But you see, that SD card was already pre-formatted, and all I've done is copy a few files to it. I don't know, let's try and power cycle it. Maybe reseat the SD card. I can see what's coming. I'm going to have to swap to a vanilla CPU, aren't I? Let's try again. Try and move that drive just so it's not rubbing on the cables. And it's not too much effort for me to take the CPU out and just put a normal one in. And there is a chance, because we've got 3.1 here, that's the issue. You know, with it Workbench 1.3. I don't know. You see, these are the drives and things here. They're all from the hard disk. And so I think we're correct in going mount here. What I may need to do is go and format that card again. Not a DOS disk in DS0. Or SD0, not DS. Right, I rewrote the card. There doesn't seem to be anything wrong with it, to be honest. I've given it one more try and I'm going to swap the CPU over. Because I'm going to call it and say it's going to be PiStorm. Yeah, so I tried it a third time there, it didn't work. Yeah, it came up saying not a DOS disk, so I'm calling it and saying it's going to be the PiStorm. This is one of the things with the PiStorm, yet another thing with the PiStorm. Don't get me wrong, I think modern versions of the PiStorm, like the ones for the 1200, they're very compatible, no issues. This original one, you get this interrupts problem. Yeah, there was no support for the correct way it handles interrupts, you know, like edge triggering, level triggering, whatever it is. And as a result, lots of things just didn't work with it. Now, one problem I have here is its turn pins into. I can't get this up without having leaving them on the board. I don't like doing this, damaged traces. Yeah, the point is here though, it's turn pins. Oh, it's turn pin into turn pin. It's alright. I'm whining about nothing. Ignore me. Nothing to see here. It's a 10 megahertz one. This is a 68,000 P10. So it should work, but it will work up to 10 megahertz. I'm trying to get it into turn pin. It could be fun. It looks alright. Let's try that. Let's see what happens with that. Should boot straight away this time. Yay. That's good. We aren't going to be playing Outrun on this spec of machine, that's for sure. Because that's one of the things I put on the card, but I've got Tiny Bobble on there and Tiny US, I think. One of those hopefully should work. Right, there we go. Plain vanilla desktop, no hard disk or anything. There we go, I don't know. I mean, that's saying that the floppy drive has got a read error. Now, This is what I don't get. It's like, which drive are we talking about here? You know, it's saying that the workbench disk has got a read error. So, granted, that floppy drive is not great. That might be in the read error we had a minute ago, but I mean, reseated the disk and then it was alright. But it then froze, didn't it? It didn't really freeze, it just did nothing. We just had that Icon X window open doing nothing. I do wonder if this SD card's too big. At 32 gig. Seemingly nothing. I don't know. Like, does it think the card's not in? Is the card not clicked in? Is it just taking ages because it's going through 32 gigabytes of fat? I don't know. I can't see any flashing. Oh, I can see activity. The LED is flashing. So it's looking at that drive, I think, or trying to. It's worked. That just took flipping ages. There we go. So it's me being impatient. SDBox. Nightmare. Tiny bubble. Let's try Nightmare. Yeah, so performance-wise, I think you get about 350k per second. Which is going to be... Hang on. Oh, we haven't got WHD load, have we? Yeah, so we can't play either of those because I don't think no, Tiny Bubble works. I think I don't think that needs WHD load. Oh no, that uses WHD load as well. Why have we got multiple folders here? I've got Tiny Bubble there. I've got what? I think you can launch it without WHD load. You can go into there. You can just launch that. Maybe. Yeah, there you go. You don't actually need WHD load for Tiny Bubble. So this is coming from the parallel port. I mean, it's a cool little project. How beneficial is it really to people? I don't know. SD card, great, because you can stick things on the SD card and get things really easily into your Amiga. But you can kind of do that with the Gotek anyway. But the issue with the Gotek is you're at the mercy of the limit of the size of the storage, aren't you? So like an ADF, how big is an ADF? 880k. And you've got to have a .adf file, which means if you want to transfer files from your computer, you've got to somehow, you know, in an emulator maybe, get them onto an actual ADF and then stick that ADF onto your USB stick, stick it into your Gotek, blah, blah, blah. The thing with this is you can access the SD card, FAT32, you know, on Windows 10, Windows 11, you just stick it in and it's there. And the files are there, and you can drag files and folders and LHA files across onto it and connect, you know, back up this way really quickly. So it's kind of similar in amazingness really to the compact flash, you know, the PCMCIA thing with the 1200. That's currently how I transfer files. You know, I stick them on a compact flash card, stick them in an adapter, and then stick that PCMCIA adapter into my 1200, and I can access them. So this is, you know, a little bit easier than that. It's a bit slower, quite a lot slower, 350k per second, but it's booted, you know, and the game's loaded here from the parallel port. Maybe marginally faster than floppy, but nowhere near as fast as a hard disk. So it is very impressive. And what I should do now is try and fit the LEDs. I don't know. Like that bodge fix. I guess one of them's maybe a power LED and one of them's an activity. I don't know, so I'm just going to stick one of the LEDs into the holes and see what happens. Nothing there. That one. Nothing there. Flip its orientation. Hang on. Yeah, so the long leg goes to the round pad. Does that make sense? Because if I just wedge that in that back there, you can see with its long leg to that round pad, it's on. So one of them must be a power, one of them must be an activity, and we can try that. I can just put that green one now into the other one, the other space, and we'll see if that one flashes. You know, I'll wedge it in there just as we choose to mount. And then I can solder those in and get the hood on. We're all done, I think. Yeah, I think it needs a specific firmware, maybe. Because I vaguely remember him saying a few minutes ago something about the activity LED, certain firmware. So this is the thing, my firmware might not be supporting that LED. That might be the issue. I think it's safe to say that the way this is wired now, I'll just confirm that again. The square pad is the shorter leg. The round pad is the long one. The round one's the long one, so I'll fit those with the round one to the long. And in terms of how do you get the length right, I think it's safe to say that way. So in other words, you put the LED in place, you push it into the position there, so it's like that, and solder it when it's like that. Because then, you can't get it wrong. It should be perfect. You can't get these so they protrude too much, look. That's not something I'd thought about. Right, that's just right. Right, I'll go and find some screws. I'm not really sure what size screws to use. You know, when someone mentions something to you and you're not listening properly, you mentioned something about the activity LED. Anyway, he got back to me. I asked the question because last night I looked at the schematics, tested the connectivity. I fixed the reset, so you can see, and two things actually. There's a solder blob there. That's for one of the connections because it wasn't joined to the chip here, but it's just like I think it's TX or RX. And then the other one was the reset because I joined the jumper there with a little bit of wire, so that when you do Control Amiga to reset the machine, it'll pass the reset through from the power port to this and reset the Arduino. And the damage to the through hole there meant that the reset wasn't connected to the relevant pin on the chip. So anyway, I did those things. Didn't make any difference to the LED. And then he's come back to me this morning and said, you need to use my fork of the repro, you know, the code. And the LED should work. So I've just done that. I've did exactly what we did before, just took a copy of his repo, you know, his code, instead of the original. So I'm hoping now we get some activity on that yellow LED, switching on. And you never know, it might be more stable, it might be faster, I don't know. Because one of the reservations I've got right now is the speed of it. It's incredibly slow. It was quoted to be 350k at max, you know, as like a throughput. On sysinfo it's come back at 89k, which is very slow. I mean, it's usable, but it was very slow on the previous firmware. Maybe it'll be the same on this one, but maybe we'll have the LED. I don't know, let's just see. I'll run sysinfo again. The other thing I discovered as well, some of those weird issues where it's coming up, you know, about there's a corruption on the card, you know, it's sector something, and it was in German, I couldn't quite read it. That relates to the SD card. It's got a 32 gig SD card. Yeah, you've got to have a maximum of 4 gig partition. You know, I think 2 gig partition, 2 gig partition. So I've ordered some 4 gig cards actually, because I can use that 32 gig card in something else. Anyway, I'm now going to run the mount command. Let's see what happens. Right, 3, 2, 1. I guess when it finishes the loading here, and the red LED there starts flashing. I'd expect this to start flashing maybe. Or it might be when that's finished flashing in a minute. Oh, it's doing it now, look. There we go. The yellow LED does work. So, all is good. I think that really concludes that. Just need to do some testing of it now. And I haven't found a way to mount it in here, because, you know, the holes here, they're quite big. You would need like really wide thread screws. So I'm not really sure what screws were intended for this. And I'm not even sure who created it. I mean, I could stick some tape or something down the sides here just to secure it. I might do that, I don't know. I do wonder if this was designed for some of those little brass inserts, like you thread your insert in, and then you can use your, you know, put your screws on to hold in place. Maybe, I don't know. So if I go into that now, yeah, LED flashed. That's really cool, it is working. LED flashing. Oh no, we've got that error back again. Oh, it's so annoying. But I think that this is caused by the fact it's got 32 gig partition. Right, so I found a 2 gig card, and that's working now. It's weird how that other card would work the first time and then it doesn't work the second time. Like something does get corrupted on it. So if we do drive speed test here, it's going to come out slow, I'm sure of it. Let's see. I mean, this SD card, or micro SD card I should say, is going to be slower than that other one. And I know that because when I stick that in the card on the PC, I copy and paste to it, it goes bing, straight away. This one, it was like I got a progress bar, or it copied gradually the files. So the write speed on this card is way slower than that 32 gig. And of course I could use the 32 gig. I could partition that into two 2 gig partitions and just leave the rest of the drive unusable. But that seems a waste of a 32 gig card, and I'm always short of those large cards like that. So yeah, we'll try it with this 2 gig one, and I've ordered a couple of 4 gig ones. 4 gig being ideal because you could just partition that into 2. I mean, obviously I could split the 32 gig one into 16 2 gig partitions. But I mean, that would be crazy. The more partitions you have in Amiga OS here, the more chip RAM it uses up, generally. Or not necessarily chip RAM, RAM in general. You can see though, it's taking ages to come back. I reckon it's going to be about 90k again. There you go, 100k. So it is faster now. It's faster with that card versus the other one. Even though the other one runs really fast on Windows. It's working though. I'm very pleased. Let's try Tiny US. Yeah, the LED's flashing, stopped. There we go. It's pretty darn good. So I spent a lot of time messing around with this. It's currently not booting, it's not working with the PiStorm, and it's glitchy. So like, I get those corruptions you saw intermittently. I'm changing all of these pull-ups from 10K to 4K 7s, making them, stronger pull-ups to the VCC. And that was reading one of Suko Perez's original comments when he came up with the idea of putting some of these pull-ups on there, actually. And yeah, the point being, 10K is quite a weak pull-up. Right, yeah, still a bit of flux on there. Anyway, I want to test it. When I fit the first two 4K7 resistors, it was then reliable from floppy with the PiStorm. But there you go, bad number again, look. So, it's not made any difference, has it? It's really strange. Got one more to replace, I'll do that one as well. So, TF536 here now. I copied the 4 files into the relevant places. And let's try here. Just looking at the card. So yeah, the problem seems to be the PiStorm. And there we go, SDBox mounted it fairly quick as well. Is it going to be any more reliable, is the question. Because the thing is, you can go into things and you come out and then it doesn't work. Maybe the drive speed test here, let's just quit out. Let's just go into one of these folders. Go back in again. Seems alright. Maybe it flakes out after the drive speed test. Hang on, that's the CPU speed, isn't it? Well, at least you can see what the 536 performs like. There we go. Then if I do drives, this never comes back with results, certainly on the PiStorm. So let's do speed. The LED on the SDBox is on. Yeah, oh wait, it came with the speed. 316090. So the PiStorm seems to be the cause of the issues with the PiStorm, if you see what I mean. That's not bad, 316k. But the key now is, on the PiStorm, after I've done something like that, it wouldn't respond normally. In other words, I go and say it again, I'd have an error by now. And it's launching. There we go. So alongside the 536, it works perfectly. We've got 4K7 resistors on there at the moment. I'm just going to leave it that way. Yeah, and that weirdness is back. I booted there, just a quick reboot, and as soon as I ran the mount, it said no disk present. And it was the same with the 10K resistors, so the 4K7s haven't affected this. I'll take the card out, put it back in. Right, now it's looking at the drive. So there seems to be something to do with the acknowledgement of the fact that media in there. Now it's worked, it's mounted it. So, I don't know. It's very strange, it's like the reset maybe didn't get through properly. It didn't reset itself. But having took the card out and put it back in, it then sprang into life. So I mean, it is working. It's working a hell of a lot better than it did on the PiStorm, without a doubt. Just got the 536 port there. Let's just take the card out. Yeah, so it's automatically detected it there. Put the card in. Not doing anything. So yeah, the insert remove is a bit hit and miss. I can show you that here. It's like I took it out and then I put it back in. The LED flashed that first time. And now it's not doing. Don't know, let's try and mount it again. I don't think you need to mount it again, that's the thing. Unless it unmounts, but I don't think it does. It says no disk present. Yeah, so it's doing that again. You see, there are parallel port differences between the different revisions of machines as well. I can't help but wonder if that's something to do with this. I think I might try that same eject insert, just for the stock 68K and booting from floppy, just to see if it's any more reliable at a lower clock speed. Maybe it is about the SD cards, because I've read that, let's say, some of the SD cards, I think Suko Perro, when he was investigating some of these things, he worked out that the SD card can be a problem. So I'll have to wait for those new 4 gig ones to arrive, but I think the Kingston ones, see what those are like. Right, I'll run the script again now. Right, I'm running the mount. No disk present again. And then what I did last time is I took it out, I put it in. Now look, it's working. So it works that first time. It doesn't work after that point with the 536. Yeah, it's mounted it. So certainly the V2 with the firmware I'm using here, it seems a bit quirky, let's say. Doing a speed test. Yeah, 316k per second. That's not bad. Forget what a floppy is. It's like, it's quite a low amount, isn't it? Let's just put the floppy in. Yeah, look, so a floppy, 22k per second. So you do the math. 22k per second versus 300k per second. It's certainly very good on the 536, but I'm not sure about this issue about disk change. I mean, is it really a big deal? No, you can still transfer files and things without any issue. But the minute you eject it, the icon disappears on Workbench, that's fine. And then when you stick it back in, nothing. Like the Amiga's not detecting the disk change. Yeah, there is no resistor on like a switch or something for cart detection. So, I don't think that's the case. I've gone back to stock 68K. I'm going to test that same thing here now. So I'll mount the disk. Right, stop flashing. There we go. We've got SDBox. So I'm going to remove the card. Disappeared there. Plug the card back in. It's flashing again. You see that? So it's all about the 536, I think. I think it's all very well that you get faster performance to the high CPU, but then you start to run into some glitches and issues. And I think that's the issue with the PiStorm. I think the PiStorm is just too darn fast, which is why it's coming with that invalid number error. There must be something that's not been thought about in the design here, where the throughput you're capable of on your CPU can start to cause you a problem over here. I'll try it again. SDBox is on the desktop. Unplug. Icon's disappeared. Plug it back in. It's coming back again. So yeah, that's one issue, I guess, that we've identified. I mean, don't get me wrong, I'm not trying to be critical here. I'm spotting these issues. We had an attempt there to try and resolve by changing the resistors. But it goes a bit deeper than that. There might be some of the flaw in the logic or something that could be addressed that might mean the 536 does work with disk changes. But we can test the next version of this in the next video, the SDBox V3. It won't follow directly from this video, it might be a gap of a few weeks or something, but we'll have a look at version 3 and see if it's any better. So as far as the build's concerned, I'm pretty convinced that's complete. Yeah, we did a speed test here before on a stock CPU. It comes up like 100k or something, I think, doesn't it? I can try that anyway. Something I just remembered, there's a newer version of the SPI SD.device, so I'm going to try that next, just give that one final try. But anyway, speed, you can see 100k, so it's still more than four times faster than a floppy drive. So the other bit of information, obviously we've got a new SPI SD.device, but I've also got a resistor array added here. I'll show you that in a minute. It's bodged on, but it's something that Bilander mentioned to me, Jorgen, that if you're testing on 3000 you need that. Someone worked that out on one of the forums there. But booting from disk with the PiStorm, we can now do a speed test, and it comes back 200k, which is really interesting, isn't it? It's not as good as the 536, but bear in mind we're booting from floppy, so we've not run set patch and the caches and all that stuff. We've not cached the ROM, and caches probably aren't fully enabled. And that might be the issue with the PiStorm in general, but booting from the hard disk, maybe it's about set patch and cache on and MMU, enable MMU, etc., and all that sort of stuff that might be interfering. I don't know. So it does work. Let's just quit out of that. See how reliable it is. Let's take the card out and then put it back in when the icon's gone. Oh, it hasn't gone this time. SDBox is still there. That's interesting. Oh, now it has. Hang on. Everything's gone. That could be a Workbench 1.3 thing, I don't know. But it just suddenly got rid of everything on the desktop there. It's all back. But we have SDBox. So you know what? That resistor array is an essential, if you ask me, because it's just behaving so much better. What it isn't doing though is running from hard disk. If I boot the PiStorm from hard disk, it just doesn't work. And what's interesting about that as well is that fix was targeting the 3000. It's better on the 500 plus here. It is definitely better on the 500 plus with that in place. Because if anything, I'm now seeing reliability I've not had so far, where I can go in and out of things, in and out of things, in and out of things, and it doesn't, suddenly come up with like imaginary corruptions. It does take quite a while, that benchmark. Yay! I'm quite pleased with that. Yeah, excellent. I really should test it with the 536 again, but I'm just going to go round and round and round down. I'll do that when I look at the next version, I think, the V3. Let's just try booting from the PiStorm again, just on off chance anything's different, but I don't think so. There, a bad number. I don't know, it's like a wrong number. You've got the wrong number, mate. That person doesn't live here, and then it says it's already mounted. And the LED doesn't flash, and ejecting and inserting it does nothing. So, I don't know. Yep, and you can see the true horror of the resistor array bodge here. It's not too bad. You have to align that, like, further to the left than you think to get on the very left edge of the first pin. You're missing the first pin, sorry. Then the first pin is a data bit here. I don't know which data bit it is, and you've got to be to the left-hand side of it in order that the other pins all marry up. And by the time you get over to the last pin, it's right on the right-hand side of that pin. Yeah, because the pitch is not 2.54, and then the pin, the pin one marking, the one with the dot where your supply goes, is just bent out, and a wire goes through around to the 5 volts there. And obviously this has been modded by me. I've got a tiny coil wire, you might be able to see it there, to fix the reset, because I did the reset mod, wire bridge that. So, and it's still got 4K7s on there, experiments with 10Ks. If you ask me, it's better with 4K7s, I could be wrong. We will revisit it when we look at the version 3 SDBox. I don't know why I want to call it a SID-box, but it's not a SID-box, and the SID-box is something completely entirely different that Miss Madeleine looked at. Yeah, so it's very cool. I mean, would I use it in anger? Like, where would I actually use this? I don't think I would. I think for anybody who's got 500 and you've not got much in the way of storage, options, hard disk, etc., then it makes perfect sense, because these things are really cheap. If you buy all the parts, they're so cheap to assemble. The performance is not bad. 200k per second with a PiStorm, if you can get it working with a PiStorm. You certainly can from floppy. 300k roughly I think. I mean, there's a bit more than 300k, I think, on the TF536. But the 536 did have that issue that you eject the disk and it doesn't redetect it. It may detect it now with that resistor array on. I don't know. So let's say I will revisit and I'll retest that at some other point with the version 3. Shiny things must not have fingerprints on. There we go. So that's not bad, is it? Right, I'll get it back into, get it into the shell, which we still haven't worked out how to deal with the screw situation, because these holes are too big. You get it like this. Chip container plugs, you know, for the end. They're just marginally too fat, so if I go on the lowest part of the wide bit and just squeeze in just a little bit, not a lot, still the same shape look, and I'm going to do this diagonal opposite. Down. There we go, it's holding together. They're even called coordinates. It's a shame I haven't got 4 of them. There we go, that'll do. That will do me. Yeah, you really need 4, don't you? Yeah, so massive thanks to Keith McGerr for sending that. Huge thanks to Jorgen Bilander for creating this PCB and the bits that go with it and stuff. And obviously thanks to the original author of the SPI interface there, you know, the device driver that this uses. It's absolutely amazing. I love it. We'll revisit it on other systems as well. Check it on the 1200, we'll try it on the 2000, 4000, 3000, etc. when we look at the version 3. And we'll see if there's any differences, what the differences between the version 2 and version 3 are. But I'm very pleased with that. It's really nice. One thing I would say is the way the SD card is mounted, you've got to put your nail in there to get it. It's one of those where you've got to try and, I can't reach in. You know what I mean? It's like the Neo SDs like this from Terra. You've got to put your nail in. And the EverDrives sometimes are, although the older ones not. I think that's gone in the case, you know. Let's switch it off. Where you've got a big gap, a gap bigger than the actual slot, if you see what I mean, for the card. It's not lined properly. The card ended up going in the wrong place. It's gone on top of the SD slot here. I had this exact problem with my PSP, and it took me ages to get the card out. There we go. So yeah, that's the downside to this, you know, the case design, that it could do with being, you know, protruded back a bit there, just to allow you to, you see, from the back you don't have a problem. You can get your nail on it, I think. I click it in and out like that. There we are. Anyway, is anyone really going to be changing the card over in real time? Probably not. It's a nice feature that you can do that. Anyway, if you enjoyed the video, please give it a like and a share. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.